So, what can you tell us about your activities, especially in Turkey? Thank you, dear moderator. I would like to welcome you all. Our company is Kuşgöz İzmir Vinç, and we are renting cranes for heavy lifting. We are a family company, established 1988. Our activities in the petrochemical industries, heavy industries, and commissioning of heavy industry plants, where the transport and lifting of the heavy parts have been done with our cranes. These are some of our services. We are located in Izmir, but we are active in all around of Turkey and also in certain parts of the world. The 2005-2006, when we had the Renewable Energy Act in Turkey, we started to have connections to renewable energies and wind especially. So we are located in Izmir, where we had the first wind plants with the Vestas turbines, and then of course cranes were needed for lifting. And then with the new Renewable Energies Act, we started with our company and started to look for bigger cranes. So this was our forecast, and that's why we did our investment in this direction. So I would like to tell you about our experiences in this area. And in offshore, besides onshore, we are talking also about offshore wind parks and how our experience translates into offshore. I will talk about that again also. So renting cranes. These cranes we rented under a certain price for certain projects. But when we started to build wind parks, we had a different motivation for our work. So, because wind turbines need heavy lifting and heavy transport, and a high number of the turbines in Turkey is also in elevated areas. So you have to put these machines into this elevated region. So it's not as easy as when you're working on a flat surface. So one of the problems we are faced on our daily work, you're commissioning a wind turbine, you're building a wind turbine, and you have to lift these heavy parts under wind. So you cannot lift every part under every wind condition. So you have to find a specific time when the wind is lower to raise these parts up in the air. So we looked at the whole world and looked at Europe and the United States for best practices. We find machines which were compatible with this type of work, and we invested in them and had enlarged our machine park. So the turbine manufacturers are building these turbines and bringing them to the areas. So we decided to make an investment for heavy lifting equipment for the commissioning, and our criteria of success was how fast you are building this wind turbine. Let me give you an anecdote. So after the licensing, you have to have your you need your permits, and after the permit you have to transport these parts and build it there. So it's a very stressful situation. So we are at the end of all of these processes. So of course this is a long and enduring process, and everybody has a short fuse afterwards. So at the end we are there, and the investors want to start operation, but the commissioning is very important because you have to be careful during the construction. The better you do the construction, the longer the life cycle will be. So, and you have to be careful, you have to mind the winds as well. So, with the coming of the wind park industry into Turkey, so we adapted into this new branch, and of course we adapted into it, and we did investments there. And 2007 we started to work with renewable energies, and we built up until then 1,500 wind turbines and 1,350 in Turkey, and the rest, and 150 outside of Turkey. So we had the opportunity to give services for OEMs. So this was, of course, different from what we have done before 2007, but with the development of the industry and with our company, we reached new dynamics, and we have 3 or 4 other companies who are working in the industry in the same area, like heavy lifting. So we have accumulated a certain amount of know-how. So we have our experience on our onshore wind turbines, and with this experience we want to go offshore, and I will talk about this in the second part. Thank you. Thank you so much. Each job has its own difficulties and opportunities. And maybe if you have a delay of 1 day, which would make the investors much more angrier than the delay that was happening beforehand, because you're at the end of the chain. Yes. So, when we're talking about offshore, of course, shipping is an important part. And we have Ahmet Paksu here from Tersan, and he's the vice chairman. So I would like to ask you to tell us a little bit about Tersan and tell us about your activities in terms of renewables, especially wind energy. We as Tersan are the biggest ship exporter. We are the leading in ship exports in Turkey. In the northwest, the European northwest is our market, is the Scandinavian market. And for a long time, we are working with offshore support ships and offshore platforms or ferries, and especially the trolleys and the fishing ships. And we have also a wind project of 200 megawatts, and we are producing also solar panels.
And when you look at the potential of Turkey for offshore winds, actually offshore winds are very much related with maritime activities, and the components are huge. One blade is 135 meters. A blade on its own covers an acre of land even. So inevitably, shipyard and port activities obligate you to use huge areas, large surface areas, and the port capacity in Turkey, I don't know if it's that suitable. As shipyards and as ports, we are ready to do pilot projects, but mass production, when you have 50 turbines, the space to store 50 turbines and the areas to pre-assemble them, we're not that ready. But still, the Ministry of Energy's goal is after 2030. So for the time being, we are not concerned or worried. There's nothing to be worried right now. But many European countries, Norway, Scotland, and Scandinavia, when you saw the projects that they do there, if we are to do in a floating manner, or if we used fixed wind farms, then both the ports and shipyards, we will need bigger spaces. But as for our disadvantages, Turkey likes production and it's suitable for production. And many components are being indeed produced from the blade to the tower. Making that compatible with offshore is not difficult. And the same is applicable for vessels. Prior to offshore wind, we had offshore oil activities, you know. Oil technology was brought to a certain technology. Up until 2015, it had its peak years, you know, oil drilling activities. So offshore wind farms is using the obsolete technology from oil, you know, vessels, infrastructures. Many vessels from there are used for offshore wind farms. So, and the vessels that are compatible for the specific activity are just recently being built. So people are saying, we don't have vessels, we don't have vessels, there is not enough infrastructure. We are only barely there at that point, because the idle vessel capacity or the idle logistic capacity was being used by us up until now from the oil, from what is remnant of oils. But we're going to have more dedicated offshore wind farm vessels that we recently started discussing. And particularly in the recent times, these offshore, in the offshore, there are cable winding vessels, service vessels, or construction vessels. Every single day, the demand is increasing. And also, as our own Turkish shipyards, every single day, we keep seeing these demands more and more increasing. Another reason for this is in the Western Hemisphere, from the western part of Suez, there are many alternatives to us, because certain components or certain vessels are being, they don't have the option of having them in the Far East for logistics purposes, not for vessels, but the components that will be used for offshore. So Far East is not a threat to us. So as Turkish shipyards, from a competitive standpoint with European shipyards, we have a huge competitive edge. And outside Turkey, when it comes to vessel building activities, particularly, of course, there is the Netherlands, or in Norway, you know, there are companies that have been doing this for several years, but I don't think that they would be as compatible as us for mass production. I don't see many alternatives. So for offshore wind farms, the technology will, and the production will shift to Turkey subsequently. So, and Turkey will be without an alternative, in my opinion, for shipbuilding. And also we can say the same for different components, and hopefully we will do similar activities like shipbuilding. And this is all I can say for the time being. Thank you. As you know, wind, particularly offshore wind farms, is for the upcoming terms, this is one of the 12 critical industries that the Ministry of Industry has identified. There will be significant incentives and investments. And we were talking just outside in the foyer, and Mr. Slettenhar asked certain difficult questions to me. So I would like to give the floor to him now. Mr. Robert is the board of directors consultant of the Metix company. He's addressing you in English.
Advisor to the board of Metix, and I want to ask him. Okay, I want to ask you, Robert. Please please give us some information about Metix, and what are the differences between onshore and offshore wind turbine energy generators? Okay, I think you are looking for this.
Santralleri arasındaki farkı bize nasıl aktarabilirsiniz? Zannediyorum.
Yeah.
Yes, good afternoon. I'm very excited to be here, part of this wonderful event. Hopefully next year more people will come, also out of Germany, Denmark and Holland. First talk about Matix. Matix, the name is in fact Matix and Teletex, is a technical textile company based in Turkey. There are 1,300 people active working. Plants in Tuzla, in Manisa, but also in Hungary we have a manufacturing location, and in the US. So they are supplying to the wind industry, specifically blades, and recently we're making also nacelle covers for bigger OEMs in the wind industry. That's something about Matex, a fantastic company to work for. It's Turkish, I'm Dutch, as you know, and I see there are a lot of opportunities between Europe and the Turkish companies to work more together, and that's also, I think, told this morning by Mr. Erden and also by Mr. Giles Dixon about the future of Turkey as manufacturing hub to de-risk the Asian supply chain. So that is about Matex. Trying to go to the next slide. Oh, see that one? Yeah. Something about my background. I started in the wind industry in the year 2000. Started General Electrics. I worked for Siemens. I worked for Areva Wind in Bremerhaven, also an offshore wind turbine. I've been 6 years the CPO of LM Wind Power, a big blade manufacturer, as you know. And my last job was the CPO of MHI Vestas. Recently taken over by Vestas itself, so there's only Vestas offshore wind and no Mitsubishi inside anymore. Next to that, I founded in 2010 the Dutch Wind Association, Holland Home of Wind Energy, so I'm in the board of that, next to my job at Matex, where I'm my board advisor. So I have to tell something about the difference between onshore turbines and offshore turbines. First of all, the OEMs of the onshore turbines, you know all, they are quite famous. Vestas, Siemens Gamesa, it is GE, Nordex, Enercon. I think most of the companies are here. If you look at the offshore turbines, only Enercon and Nordex, they are not equipped to make the offshore turbines. You see, what is the big difference between these two turbines on the water and onshore is the size. The size is enormous. And next to the size, there's also the weight of the components. That's what you will see later. But the size of the turbine is going tremendous high. As you can see, we're aiming for above the 300 meters in a short notice. At the moment, Vestas, the 236 is 280 meters high. So it's an enormous.
280 metre uzunluğunda. Eğer bunu nakliye limanında taşıyacak olursanız ve Barış Limanı'nda boyutları bunlar. Ebat bu. Ve küçük ve yeşil bir alanda bunun büyüklüğüne baksanız, mesela rüzgar türbin alanında bu yeşil alan bir futbol sahası büyüklüğünde oluyor. Gerçek bir büyük türbinin büyüklüğünü tekrar bakın ekran üstünde gördüğünüzde. Şimdi deniz üstü rüzgar santralinde bir nasele bakalım. Burada 15 megawatt var Vestas'tan. Peki bunun büyüklüğünü görüyor musunuz insanlarla? 500 tonun üzerinde muazzam bir büyüklük. Üretim sahasına baktığınızda ve neyi taşıdığınızı, neyi hareket ettiğinizi, bunu gerçek hayatta hiç görmeseniz bu nasıl, bu bir türbinin üstünde nasıl ayakta duruyor? İnanılmaz bir şey aslında.
What are the differences between the turbines onshore and offshore? Now, first of all, is, of course, the blades are a bit longer, the weights are higher, but there are also some other points. It's corrosion resistance. Very important that your parts are not rusting on the water. So that's very much needed. Most turbines are over-pressurized because that's helping to avoid the corrosion inside the turbine. Then, of course, the installation and maintenance, that's one of the first speakers also saying, is for offshore, it's totally different battlefield. If you see what is needed on vessels and installation cranes, jackups, it's massive, it's huge. Then the quality of parts of onshore and offshore is also totally different. So for offshore, you create major risk if your part is failing. And if a part is failing, you get an issue with liquidated damages from your OEM. So you must be sure that your parts are correct quality and delivered in time. Contractuals, you see a lot of liquidated damages. In case you're delivering too late, you have to pay penalties. So these are, let's say, the major differences between the onshore and offshore turbines. Below, you see the forecast. In 2019, what we thought what would be happening on onshore in 2035, and you see, we thought in that period, the onshore turbine would be maybe 5.5 megawatt, and the offshore turbine would maybe in 2035, 17 megawatt. So you can see here, that went much quicker than everybody expected. So the race to bigger turbines is going on, and there should be a limit on that. And that is maybe a part of my second session. Thank you.
Okay, thank you very much. Robert Bey'e bu bilgilendirici.
Thank you, Mr. Thank you for this presentation. That was very informative. The last presentation of the first part of our session will be delivered by Ms. Yasemin Polat from Denmark. And please, can you introduce Denmark to us briefly, and particularly about green hydrogen? Can you talk about your activities about green hydrogen? Thank you. My name is Yasemin Polat. Welcome to our presentation. I am working at Denmark, that is Turkey Energy, Nuclear and Mining Research Authority, and I am the person in charge of the group in terms of energy and technology policies coordination. I'm going to talk about various topics, and I'm going to talk about our offshore wind and green hydrogen production technologies. And also I would like to talk about the Turkish hydrogen strategy and roadmap that our minister talked about. It was founded in 2022 by Ministry of Energy and Natural Resources. And we are working on research, development, innovation, design, technology transfer, production, test, and localization activities. And we are working on energy and power and hydrogen technologies and rare soil elements and board. And we've got 5 institutes that I want to talk about. NUCAN, that is Nuclear Research and Energy Institute. We have Nuclear Technology Institute. Another is TEMEN, that is Clean Energy Research Institute. And solar, renewable, and energy generation activities are carried out. And we have another ENERAN, Energy Research Institute. Another important institute is NATEN, that is Rare Soil Elements Research Institute. From waste or soils, getting rare soil activities and the development of these technologies. and permanent magnet activities are also being carried out. This conference's topic is wind, and when we talk about wind energy, we think of wind turbines, and there are important rare soil elements, rare earth elements, and we are internationally dependent, like we are using neodymium, like Mr. Robert mentioned in the nacelle part, and we are working on those too. And boron is the Boron Research Institute. Our country is boron rich, and our colleagues are working on the research and development of boron technologies. In this slide, we're going to, these are our roadmaps. As I said in the beginning of this year, Turkey Hydrogen Technologies roadmap was published, and the solar energy roadmap draft activities were completed, and there are also certain ongoing activities, wind energy technologies, rare soils, and boron technologies roadmap is in place, and we can add critical minerals. We added that, and there are also fourth generation nuclear reactors roadmap and energy storage technologies roadmap, and roadmap for digitalization technologies in energy are what we are intending to concentrate on. And I'm going to talk about Turkish Hydrogen Technologies roadmap, but before, the International Renewable Energy Agency published this. As you can see, when you look at energy commodities, oil and natural gas are very valuable, but in 2050, hydrogen and methanol and ammonium trade is expected to increase, and also by 2050, petroleum and natural gas will be replaced by bioenergy. And IRENA's study says that hydrogen will constitute 12% of the global energy use by 2050. And as part of our roadmap, we have a vision, mission, and strategic priorities. Our vision is to develop advanced technologies and to play a leading role in the production and use of green hydrogen by developing the most advanced domestic and national technologies. And our mission is to create an effective value chain for green technologies. And our strategic priorities is using green hydrogen to first meet the domestic resources and to export the excess hydrogen to bring a foreign exchange income opportunity for our country. And also, as part of the roadmap, 20 needs were identified with 31 solutions for those. And as part of our roadmap, there are two main goals. One is by 2035 to reduce the production cost of green hydrogen to $2.4, and by 2053 to reduce it below $1.2. And the second is about electrolyzer installed power capacity, 2 gigawatts for 2035 in 2035 and 70 in 2053, 70 gigawatts as part of this report. And also, there are 13 policy targets that we identified. I'm not going to list them all, but there's an article in TENMAC using local and domestic technologies, hydrogen storage, and to develop these technologies. Likewise, these are some of the 13 policies. And now I'm going to talk about TENMAC, Technology and Product Development Projects Support Program. In the beginning of 2023, we had two tenders. One is hydrogen, and the other is K. And these tenders are completed, and we're assessing the applications, and soon the results will be announced. And here, When talking about installed capacity and looking at our national policy in 2030, 2035, and 2053, both on offshore and solar and nuclear installed power is to be increased. So we need digitalization in energy if we're going to accomplish that. And last week there was a tender announcement that we made on AI and ML and cybersecurity. And wind energy technology is going to be tendered soon, and also measurement systems for turbine systems, wind blowing analysis, and the life of wind energy systems. We prepared a draft tender, and in the first quarter of next year, we're going to announce a tender. This is all I have to say right now. And I will talk about the offshore wind, green hydrogen production potential later. Yes. TENMAC has a wide scope, and thank you for this information that you have provided. By the way, I would like to thank all the speakers for complying with the time. In the second round, I will give the floor to Mr. Levent once again, and in this part, my request from him is to talk about the services they deliver in offshore projects. What kind of services do you give or do you intend to give in offshore? This is also in-house, particularly for international projects that you have a know-how accumulation. How will you convey that to Turkey? Thank you very much. Now, in the second round, I will talk about offshore and the offshore services that are given by us, and how we will take the offshore acquisitions to onshore. There are three main themes that I would like to explain to you. In our company, from 100 tons to 2,000 ton capacity cranes are available. At a world scale, these are huge machines, and they can be used in various different industries, like I said, in petrochemical industry, natural gas plants, renewable energy, also in ports, in offshore constructions, and in other specific jobs that require these. The first topic that I want to talk about is the right equipment selection, and a country's companies investing in that equipment. Like I said, in onshore, in 2007, there was a new law, and we wanted to adapt immediately to upgrade our cranes and transportation vehicles because they have long blades and heavy and top-heavy towers. Particularly in the selection of cranes, our experience shows that the first cranes that we bought and the turbines, you needed to carry the turbines from one place to another in a mountain. So you need to choose cranes that are easily, that you can dismount them and mount them. And some have pallets. The pallets, they can be narrower if necessary. You can make them narrower. We understood that. So we made investments accordingly. So based on these lessons that we got from them, bigger capacity cranes, because we are giving services in nuclear plants, so these are used in offshore as well, but they have different technical specifications. And in our country, the onshore wind turbines, their development is thanks to us and companies like us giving services in the industry. This has to do with choosing the right equipment, and it is important to make a sustainable investment. Why sustainable? Because turbines, at least onshore turbines, grow fast, from 3 megawatts to 4, 5, 6, and the blades are getting longer, the turbines are getting taller. So along with the industry, as the the turbines get bigger, we need to continue our machinery park investments to be able to assemble them and to erect them. So we need to continue our investments. When we also made investments recently, so we acquired and accumulated this know-how. The second issue is these services that you deliver, making the assembly onshore and offshore. It's very different. And in Turkey, in offshore, for instance, we have on the floats, on the buoys, or by the seaside, we have, like in the Dardanelles Bridge or the Orhan Gazi, the third bridge crossing. In such sea structures, we have acquired experience. So we can work on the buoys, we can work in a marine setting because it's a much more humid setting. And it can lead to corrosion in machinery. So you need to choose the suitable cranes and work accordingly because there is a time pressure. And you're working with a time pressure. You're the last stage, and once that is installed, it's going to be commissioned. So in the contracts, it's not a service that you do, but they talk, there are delays and fines, there's the economic burden of it. So your marine and offshore experience needs to be very well. You need to be able to do this. And the third topic that I will talk about is, because Turkey is a peninsula that is covered with waters on three sides. So on the infrastructure projects that we work, and there are many other companies that serve like us. So this know-how is already available in our country. And the third part is, again, like I said, the installation, assembly, and erection of such turbines. It will require machinery and equipment as well as labor, manpower, which has to be very qualified. Onshore turbines, during their assemblies in Turkey, we benefited from global companies for this labor. And also our local companies, domestic companies, accumulated their own know-how too. And when it comes to occupational safety as well as doing the right job, because there are turbines that were assembled but that didn't work or function afterwards, so we had to intervene in other ways. On offshore is more specific. You're working on a sea setting and in offshore there are two parts. There is the port services, because turbines are either assembled in the ports and they are drawn with barges and then assembled on the sea, or you load them on a vessel, that vessel loads them with their own in the offshore. So there are services to be given both onshore and offshore, and these are efficient only when you add the labor on top. So labor-wise, this is relatively more new. This is newer, more recent, and a growing job compared to onshore. So you have to collaborate and cooperate with international companies, but after you cooperate with them, the qualified labor, you can move that to Turkey. You can localize that labor. And I said, Turkey started building up and accumulating know-how, and I don't think labor will be an issue. So let me wrap up. Of course, in onshore, our accumulation of know-how for the operation mentality of the wind turbines, and we have an affinity to their operation philosophy. So when it comes to, there's the industry part, of course. You shouldn't look at it as a plant only. There's the manufacturing, the construction on the shipyards, and then being loaded on the barges and drawn. So the know-how on the onshore and the offshore know-how, we are confident that we had big volume, big tonnage cranes. So I think we can easily transfer that know-how from onshore to offshore. And rest assured that we have an infrastructure. I tried to give you information in our country to the best of our ability. Thank you very much. In both speeches, you drew a scary picture first, And then you also demonstrate our capabilities in this area, and you help us to be proud, and you help us to look to the future with hopeful eyes. When we talk about wind energy, you know, you have mechanical engineering, civil engineering, logistics, ferrosteel industry, materials, metallurgy, electronic engineering. But so there's a huge range of disciplines, and we felt it really. One of them is shipping and marine industries once we started. And I'll give the floor to Mr. Ahmet Paksu once again. And about offshore, we know that you're experienced about offshore, and you have serious experiences in the marine field. So these vessels' potential in offshore and their activities, their capacities, can you explain it to us? Thank you very much. I'm waiting for the presentation. I didn't do the first part, but let me at least do the second part of my presentation.
Ya ben bu hem sizin bahsettiğiniz konu hem de
The subject you talked about, and in combination with this, where do we go in terms of offshore and where can we be active? So as you can see, we have fixed offshore wind turbines, and we see that the trend is going in direction of floating offshore platforms. And this is trending right now, and of course we would like to anchor the turbine onto the seabed, but after 50 to 80 meters, it gets harder and harder to have a foundation. So you need more systems with more capacity, and so you have to switch over to floating systems. And in terms of floating, we are a little bit confused because the technology is still bleeding edge. It's still new. I show you 3 different design types, and you will see a couple of more on the next slide. But which design will be more successful in the future is not known yet. So we're talking about something like, will the number of blades of a turbine 2 or 3? So this is the discussion we are having now. So this is a system which was used in Norway. When you make a floating turbine, you want to have the center of gravity as low as possible, below 30 meters. So you get rid of the wave effect. So in high wind, that's what they did in Sweden. But so you want 60 meters of depth, and you don't have a shipyard or a shipyard or a opening where you can build this, maybe in Sweden, but nowhere else in the world. So these floating structures, we will have a certain advantage when it comes to floating structures, because all of these structures are around 100 meters. So, and they weigh around 3,500 to 7,000 tons. So we have different designs and different structures and different weight classes. And what type of designs they are, we are beginning to have an idea about the design types. But which one will be the most efficient and the optimal solution is still not certain. And the project we are receiving are pilot projects. And a lot of floating platforms are seen as experimental projects wind farms with 6 to 7 turbines, for example. But there are some tenders, and you could do that in Europe. For a 1 gigawatt park, you need 50 foundations, and when you think about 100 to 100 meters, and that would mean 300 acres of land just to stock these turbines. I'm not talking about the transport part or the production, manufacturing part. So the Turkish shipyards, we as the Turkish shipyards have a lot of enough space and enough capacity to build those, but similar shipyards in Europe, with which we are in competition, we see that they have the infrastructure, but they don't have enough space. So of course, they will need to have serial production for floating platforms, and we think that as a location, this will be Turkey. And when we are talking about floating systems, you can pull them with ships and then add the anchors to fix into the seabed, and they have different types, so the service of these anchor types will also be different. And the construction ships for these types of projects will also be built in these shipyards. So these floating devices are more expensive now, but you can build them in a harbor or on land where you have barges, and you put these parts on it and ship them outside to open waters. That could also be a solution. And like other speakers told before, when we connect them to the hydrogen production systems, maybe I see the hydrogen as a starting point here. In the wind park, the cables from offshore parks to the land, there were some huge damages, and when you have a damage on a system which is 100 kilometers offshore, that is a problem. And then you think, what can we do? Maybe we can produce hydrogen outside on open seas, so we don't have to transport this power to land. So with the electrolysis, you can have a hydrogen production and storage. Maybe this can be also integrated into this floating device, so you have a lower center of gravity, and then you can, and if you want to have a repair for a blade, for example, you can pull them by ships to the shore where you can have repair works and then put them outside. So you have a unit where you are producing electricity, and you are using this electricity to produce hydrogen and store it. So mobilization is a huge number. And in terms of floating, we will be talking a lot in the near future in combination with offshore. And we as Turkey have a great potential on this area. That is, and together with floating, we will have different concepts. Maybe we won't need a tower, like you can see in these pictures. So floating devices bring us maybe new perspective. So we were building towers for floating systems, but maybe it was just a habit. But maybe you can have a triangle system where you have a space frame, for example. This brings new ideas, new opportunities, and the cards will be the cards will be mixed again. So we have new opportunities here. And we think we have an idea, or we have the task to produce this in serial numbers, and we have aluminum, and we have also sheet metal, and they were looking for experts in Europe, for example, couldn't find it, so they came to us, to Turkey, and so we are looking for more and more for hybrid solutions in the world now. So I think that Turkish shipyards will have a different and advantageous position. Thank you. This presentation makes us proud. We started a little bit late, but we need to work more. We have to be more diligent when it comes to time or in the use of time. So I won't be dragging out this discussion and want to give the microphone for the second round to Robert Slettenhar.
Changes to support offshore wind turbine generators. Thank you. The floor is yours.
Can I have my second one slide back? Oh yeah, I can hear, yeah. Okay. Yes, thank you for the introduction. I have maybe a different way of presenting, because I will dig in via some questions and statements. So there's a different way of approaching, and I'm approaching it out of my global view, what I've experienced, and how I look at Turkey as the manufacturing hub, maybe for Europe, to de-risk the Asian supply chain. But to become the manufacturing hub, you have to make some principled decisions how to become this. And that's what I want to show or share my vision with you here. So, yeah, first of all is local content. Is local content requirement needed? Now with ISTKA you have 65% local content, but for offshore wind, will this create job creation or not? Because that is the reason that you choose for local content, job creation and getting more work in the country. That's of course fantastic. However, if you look at the OEMs, they struggle to localize per country, because Turkey is not the only one who's asking localization, but also other countries asking for localization. So for an OEM like Vestas or Siemens, it is getting more complex to say, okay, this part is made in Turkey, this part is made in France, this part is made in Spain, this is in Denmark. So it creates a more complex supply chain. What you can do, of course, in Turkey is looking at the big structures, what is difficult to transport. So the blades, of course, are number one to localize, and that's already happening with the 4 blade manufacturers you have. The steel structures, it's a logical choice, because moving towers and steel support frames, transition pieces, it's not needed. You can make them local. That's a fantastic opportunity to grow in the wind business. Also composite parts. You have a background in textile manufacturing, so also in composite parts manufacturing based upon technical textiles production. So these parts you can easily localize. But the first question remains, do you want to localize or not? And what is the limitation of the localization? I think it's better to lower the localization degree than put it in a higher bar. And why is that? Because if you buy a BMW, if you want to sell a BMW, or let's say a car, in a country, and each country asks for localization, it is economically not working. And in fact, you're making an increase of your product. So in the end consumer of the electricity pays more. That's my first statement. The second one, will Turkey limit the size of the wind turbines? That's an interesting question. And it's coming out of the localization also. So if you have seen, the turbines getting bigger and bigger. And in 2019, we thought, it takes maybe 15 years before the turbines are so big. But in fact, in a few years, they were bigger than we ever could expect. So we are now in the 15, 18 megawatt. But if we go to 25 or 30, what does it mean for the infrastructure? So you can also say we limit the size of the turbines. And in fact, that is something what General Electric is doing in America. They're looking at limitations in America for the offshore wind. So not the biggest one, but we say, okay, we go to 10 or 12 megawatt. And then your whole infrastructure, what you have, you can use. You can use your vessels, you can use the land, you can use the local manufacturing. So there's a benefit from it if you choose to maximize your turbine size. That's something to consider, but it's a political decision. Just that we think about it, what's the consequence if you choose for localization together with a limit of the turbine size. Here you see a picture of an installation vessel. This one has been recently made by Van Oort in Holland. It's manufactured in China. So I think it's better to look at Turkey, at your locations, if you can manufacture these kind of vessels. That will be a fantastic opportunity because you need these in the future. But you can see this one is for 20 gigawatt installations, 20 megawatts, sorry. If the turbine is getting bigger, you need a new vessel. Lead time 4 to 5 years. So you have to plan ahead. Then, yeah, maybe you have said already a lot about this by my previous speakers. Will the harbors in Turkey be capable of facilitating offshore wind till 20 megawatt? So if it's become 25 or 30, can you handle it still? So because they're growing and growing, we have to think, okay, what will be in 10 years from now be the regular turbine size? And are we equipped with the harbors to be prepared to handle this? So the choice of limiting the turbine size, or you give it for, let's say, unlimited, makes the decision of the underlying infrastructure. So that is, in a nutshell, what I want to say about the structure of the country. We can localize, we can not localize. We can maximize the turbine, we can not maximize the turbine. And are we ready in Turkey to handle both options, also the bigger ones? Or we choose for lower sized turbines? Offshore wind. I would say offshore wind is great. It's a great future for all of us. And as this morning was stated, the European Parliament wants to de-risk the supply chain from Asia. And I still think, and that's what I'm knowing out of my experience here in Turkey the last 2.5 years, Turkey is the manufacturing hub to de-risk for European supply base. If we don't use Turkey, we have no manufacturing industry in Europe. So we have to de-risk, and I think Turkey is a great opportunity for this. Thank you.
Çok
So it was a very informative and horizon broadening presentation for all of us. So the policymakers and the industrialists and investors should come around the table and discuss. And your presentation showed us again that there's a lot to discuss. So our last speaker will be Yasemin Hanım. And She will talk about the studies for creating or producing green hydrogen with offshore wind parks. So what is the production potential of green hydrogen with these offshore wind farms? We have three models when it comes to this generation of green hydrogen. In the first model, you see we have the wind parks, but for the production of hydrogen, you need electrolyzers and storage facilities. All of these are onshore. And the idea behind it is to transmit this electricity via HVDC cables on onshore electrolyzer facilities to produce hydrogen. In the second system, you have a offshore system, but the electrolyzer is on the production site. So you are producing hydrogen, green hydrogen, on the production site of energy, and you transfer it to the shore. And in the third model, you have several wind turbines, and all of the energy comes to a central electrolyzer, and the hydrogen is produced here and is stored onshore via pipeline. And here on top, we have the report in regards of Turkey. And Turkey has a 12 gigawatt offshore potential, which is anchored to the seabed. And in open waters, there is a potential of 63 gigawatts for floating devices, turbines. So in total, it's 75 gigawatts. And on the right side, you see in the study from 2023 on 4 areas of Turkey. And we have here stable, anchored, or floating turbines with 54 gigawatts. On the left lower corner, we have Bandırma, Bozcaada, Gelibolu, and Karabiba, 4 areas that are a candidate for wind parks, and we are still on the ministry is doing a study for this research. And these numbers are from our national energy plan, and we have the goals for 2035 and our established capacities. And for up until 2035, we are expecting an installed power for electrolyzers of 35 gigawatts, which is 0 right now. We have 25 gigawatt wind park installed power. Now we have only 12 gigawatts. And the 2035 goal is 5 gigawatts of offshore wind parks installed capacity. Now we have 0. And we have we have no nuclear installed capacity, and we are planning to raise it up to 7.2 gigawatts in 2035. So 5 gigawatts of installed electrolyzers. So what does that mean? 5 gigawatts of installed electrolyzer power. So with an electrolyzer, we can produce 625,000 tons of green hydrogen per year with 5 gigawatts of electrolyzers. So we need 31,250 gigawatt hours of energy. And to produce 625,000 tons of hydrogens per year, we also need 9.4 million tons of water. So this hydrogen will be used in different areas. So this means that we will have less 4.5 million tons of CO2 equivalent less greenhouse gases, because we are not using oil or natural gas, so we will have a decrease of 4.5 million tons of less CO2. That's how we can explain it briefly. So 5 gigawatts is our goal for 2035. This is the energy we need for our electrolyzers, and 31,250 gigawatt hours of energy is needed for the electrolyzers. So what does that mean? That means 2.6 gigawatts onshore and offshore energy, wind energy, and or 5.2 gigawatt of solar energy, or 1 gigawatt of nuclear energy. But if we want to produce all of this energy offshore, then we need an installed offshore capacity of 10.5 gigawatts to produce hydrogen from a 5 gigawatt electrolyzer. So in our hydrogen roadmap for the goals, when we put them all together for 2030, 2025, and 2053, so we are planning to have a electrolyzer capacity of 2 gigawatts for 2030. We will be producing 250 tons of hydrogen. This is planned. And if we would have to generate all of the energy from offshore, then we will need 4.4 gigawatts. For 2035, we thought it was 11 gigawatts. And for 2053, we have a higher expectation for electrolyzers. So it has to be 70 gigawatts of electrolyzers. So if we want to produce all of these hydrogen with offshore energy, then we need 154 gigawatt installed power on offshore plants. But in the World Bank study, the potential of Turkey is defined as 71 gigawatts. So with 154 gigawatts is not realistic. So we will have to support it with solar energy and nuclear energy. Thank you so much.
Thank you very much. This expanded our horizons. It was informative. It was hope. It gave us hope. The title was Onshore Wind Success Story, Can It Be Carried to Offshore by Turkey? And I would like to add another question to this question, because I believe that it is much more important. The peace and peace of mind success story. Can Turkey carry it to the Middle East, the peace setting in domestic? It was twice in the same day. I have to think of it, and I want to repeat it at every time. I have to repeat it, and I have to say it so that my heart doesn't soften. And Israel today in Gaza and in Jerusalem, which is the holy place of all the Abrahamic religions, and I would like to denounce the massacres that is reaching to genocide, and I am inviting you to raise your voice through social media and boycotts, and thank you very much for listening to us, and I would like to thank our speakers for their speeches.